Okay, so welcome back to another video. Today we have a nice little, I guess you can call it like a 2025 integral. I guess you could also say that because this is the first video of 2025 after coming back from a long hiatus. So what we have is we have an improper integral integrated over the reals of 2025 to the power negative the absolute value of x divided by 1 plus 5 times, or 5 to the power inverse sine of sine to the fifth of x dx. So a lot of things can be a little bit complicated and off-putting since you have an absolute value as an exponent and you have an inverse inside of a trig function for sine also as an exponent as well. But you don't need to worry too much about that because of course you can probably guess that your first intuition is we're going to be doing some u-substitution, which we will be, but the strategy behind this is we're actually going to add double the integral of what is given after applying such substitution that's such that it actually cancels a lot of things out and it makes the integration a whole lot simpler. So going with that procedure, there's not too much to get overworked with all this stuff, as I just explained that it'll make everything a lot simpler once we actually perform the necessary calculations. So why don't we actually just jump right in? So we have the absolute value of x, so let's actually do a little, of course, a u-sub. We're going to let u equals negative x, and if I actually just rearrange it so I have x by itself, it would be important to replace the dx after we perform the differentiation. So that means I have that x is equal to negative u, and differentiate both sides, we have that dx is equal to negative du. So going forward with this, and I think it's also important because I did mention we were going to do add a double of the given integral we're actually going to do after performing the substitution. So let's actually notate this by calling our given integral, capital I. So with this the case, so that means now our new integral. So of course we're going to change our integration of bounds. So we have infinity, and then everything is going to be in terms of u, so that means this will be a negative infinity on the top and a positive infinity on the bottom. We have a 2025 at n to the power, so let's see, negative, and then inside the absolute value, of course, that's just going to be negative, the absolute value of negative u, all this being divided by, so 1 plus 5 to the power, the inverse sine, and then inside our function is going to be, so we have, x is negative u, and because that's such that it's an odd function, I can actually move that negative outside, so I have a negative sine to the fifth of u, and then finish it off with replacing this with the negative du. So with things, we can actually, of course, simplify some things down, and then we have the following integral, of course, that we have a positive infinity on the bottom and a negative infinity on the top, so we just switch. That will become a negative, but that will also cancel out that negative from that du we actually just differentiate from before. And so one thing to note is that we have absolute value negative u, so that's actually, you can also say that's the same thing as still a positive, well, just the absolute value of just u by itself, so we can actually replace that. So negative infinity, infinity, so 2025, then to the power negative, and then this will just be the absolute value of u, we just replace that. And then next is on the bottom, we're gonna have, so it's just gonna say the same, so 1 plus 5 to the power inverse sine of, it's actually supposed to be the negative over here, so negative sine to the fifth power of u, and then finish it off, and then just leave it with du. Okay, so now this still looks complicated, doesn't it? I know. So before we actually do any more simplification, there's some things we can actually notice. So I'm gonna write this as the next line. So what you wanna know is that negative sine of, or inverse sine of negative sine to the fifth to the u, also an odd function as well. So you could actually just take that negative outside and put it with the associated with the inverse sine. So basically this is going to equal to the negative of inverse sine, and then this is just will be sine to the fifth of u. And then afterwards, what we're going to do is that we're actually going to multiply and divide that same number that I just mentioned, 5 to the power, this entire expression that I just discussed. So this will lead us with, of course, negative infinity, positive infinity. So let's see, 2025, and then what is it, to the negative absolute value of u, multiply this by 5 to the power inverse sine of sine to the fifth u, so excluding the negative, that's what I meant to say from before, and then all this being divided by, so 1 plus 5 to the, so inverse sine of negative 1, negative sine to the fifth of u, then multiply that with the same thing over here, 5 inverse sine of sine to the 5th of u. So as mentioned, so du, negative will go outside, and as you'll notice that if you actually just distribute this entire term altogether, we're just going to be just 1. And then the next step is we're going to actually add the two integrals together. So of course we have that we use our given, and then what we have here is we use our substitution over here. So to put things a little simpler, so then let me actually write this out in full. So negative infinity to infinity, 2025 negative absolute value of u times 5 inverse sine of sine to the 5th of u, then this being divided by, so that means 5 inverse to the power inverse sine of sine to the 5u, and then add this with 1. And then du. So now with this the case, so now we can actually just add this new substitution, add that together with our given, and so we have a double, so that means 2i. And so with this being the case, they share the same factor, 2025 to the power, going back to the world of x, it's a dummy variable, so negative absolute value of x, and we can factor that out. So negative infinity to positive infinity of 2025 to the power negative absolute value of x, factor this out of 5 inverse sine of sine to the 5th of u, and then add this with 1. All this being divided by 5 to the power inverse sine of u, or inverse sine of sine to the 5th of u, and then plus 1. And guess what? You are going to notice that we have some terms that are going to cancel, simply leading us with just negative infinity to positive infinity of 2025 to the power negative absolute value of x, then dx. See, now we just made things a lot more simpler. Well, now in this case, it probably may not look simple when on first glance, but what you can do is apply the properties of absolute value functions. We can split this up in terms of like two integrals. We'll use this such that we'll have it divided between negative infinity to 0. So then that would the equation lead to be 2025 to the power x, then dx, and then add this with the integral from 0 to positive infinity of 2025 to the negative x, then dx. Okay, so that's what we have so far, and of course, an integral of this type is actually, easily can be computed if you just remember your tables, or if you want to take the long way, feel free to do so. But doing so will just lead the following. We are going to get that our first integral over here is going to be 2025 to the power x divided by ln of 2025, and then evaluate this from your bounds of negative infinity to 0. And then the same thing can be said over here, and said now we have a minus, so 2025 to the power negative x divided by ln of 2025, and then evaluate this from 0 to positive infinity, which of course going forward here, then this will just lead us with just 1 divided by ln of 2025 for the first term, and then if you plug negative infinity, you're going to get that's just 0. And then next thing is that do the same thing. First term is going to be 0. You plug in 0, you're going to get a positive. So plus 1 divided by ln of 2025, which of course that's still going to equal 2i, and therefore you just divide 2 to both sides of the equation, then you're going to get that this is simply just going to be 1 divided by the natural log of 2025. With that being our final answer to our 2025 integral, as I just denoted from earlier. Just like that, we just make things a whole lot simpler with just breaking things down and then doubling the integral such that it comes down to a simpler calculation with a simple integral like so, with it calculating the simple bounds. So there you have it. And yeah, that's pretty cool if you ask me.